Okay, welcome to chemistry once again. We have practice today, right? So hopefully you just came off of a video where you were learning about Lussac's law, right? And Lussac's law states that the pressure is related to the temperature directly under one set of conditions, which is equivalent to the pressure over the temperature in a second set of conditions. Okay, so here's your problem. Let's take a look at this. At constant volume, the final temperature of a gas sample is 473.20 Kelvin, with a pressure of 340.41 kilopascals. Okay, so this is something that's a little bit different than the last video. Kilopascals is a unit for pressure, gas pressure. Typically we've been dealing with ATMs, but we need to know that 1 ATM is equal to 101.325 kilopascals. So we have some converting here. If the initial pressure of the gas was 400.00 kilopascals, what was the gas's initial temperature? Okay. Keeping along the lines that this is Gay-Lussac's law, we're going to use this because, well, it says Gay-Lussac practice, but we also know that the volume is constant, and we're comparing pressure and temperature. So as always, pause the video at this time and take your best shot at this. Okay, the solution set. Let's take a look. Okay, how do we solve for this? So, breaking down the variables. We have no idea what the first temperature is. So that's our big variable. That's the big question mark. We know that our second pressure is 400 kilopascals, but we need to convert that to ATM. And my marker ran out over here. All right, there we go. So we know that 1 ATM is equivalent to 101.325 kilopascals, right? This is our conversion factor between the ATM and the kilopascal. My kilopascals cancel, so this converts to 3.9477 ATM. So that's our second pressure. Our second temperature is given in Kelvin. We don't need to do anything with 273.15. It's already given in Kelvin. And our second pressure, I'm going to also convert. Oh, what happened here? We have two pressures. Constant volume. So this is our first pressure. Excuse me. We had two P2s up there for a second. So our first pressure is converted, and our second pressure was given as 340.41 kilopascal. So once again, I multiply this by the conversion factor. That 1 ATM is equivalent to 101.325 pascals. My kilopascals cancel, and our second pressure is 3.3596 ATM. Okay? So we know all the variables except one, the temperature under the first set of conditions. Now we can plug in here. So we're trying to solve for T1, right? So if I multiply both sides by T1, T1s are going to cancel. Okay, if we transpose this, we move T2 to the other side by multiplying both sides by T2. This gets a little sloppy. And then we divide both sides by P2, or multiply by its reciprocal. So P2's cancel. So when we clean all this up, we get that the temperature under the first set of conditions is equal to the second temperature times the first pressure divided by the second pressure. And we know these three variables from the previous slide. So it's simply just plugging these values in. And here's what we got. Here's our T2. Here's our pressure 1 and our pressure 2. Right? Our kelvins are going to cancel. A K for a K. And we're left do here. There should be ATM. Come on, Mr. Brown. Slip in here. ATMs cancel, and we're left with Kelvin. I don't know what I was thinking when I made this slide. So, ATMs cancel, we're left with Kelvin. And notice what happens here. Okay? If we look at this, our temperature went from 877 and it went down to 746, okay? And we also see the same thing happen to our pressures here, right? We get a pressure drop as well. All right, so this is Gay-Lussac's law. As always, we're going to look at some more of these problems in class, and ask me questions if you don't understand this material. We have a couple of videos coming up on our last gas laws, which are the ideal gas law and the combined gas law. Until then, I'll see you in class and keep on practicing these things. All right, good luck.